Now, as we've just seen, dividing out a factor can help us find zeros, and we're going to use this as we look at the problems on page 42. We're going to start with A. A is pretty straightforward. All you really need to do on A is just divide out that x like it says. So you're just basically taking out a GCF of x, so that'll give you an answer of x, and then an x squared plus x minus 2. So that has given you one factor. If you wanted to, you could attempt to factor that again. And the truth is x squared minus x minus 2 would factor again like a trinomial. I would need something that multiplies to negative 2, adds to 1. So those numbers are positive 2 and negative 1. So I basically have an x plus 2, and an x minus 1. And that gives you, if you wanted a graph of that, we will not graph all of these, but just to illustrate, if you wanted a graph of that, you would have x-intercepts at negative 2, at positive 1, and at 0. So you would have a graph that looks something like that, where it goes up across at negative 2, back across at 0, and then back at 1. Gives you a rough idea of what it would look like. But the problem when you get to one like B is you're not just dividing by an x. You are dividing by x, but it also has a minus 1 there. So synthetic division is an easy way that allows you to divide this out. Synthetic division is one of those things I strongly encourage you to be patient with it. We'll work a few of these together, and it'll take a while. It'll look a little weird at first, but once you get the trick of it, it's a pretty easy process. So just follow along with me and let's try this synthetic division. The first step for synthetic division is I find the zero by either by graphing, or in this case, they gave me the factor of x minus 1. So I can say, well, if x minus 1 equals 0, that means x has to be positive 1. So I'm going to take that factor of x equals 1 and put it in a box in front of my equation. So that's x equals positive 1. And then I'm going to bring down my other coefficients. My other coefficients in this case are a 1 because I have 1x cubed, a 0 because I have 0x squared, a minus 3 because I have to include the negative as part of my coefficient, and as a 2. Now let's explain real quick where I got that 0 from. You notice I went from x cubed and a plain x. There was basically a 0x squared that was not written down. It was kind of understood, and you have to hold that 0 has to be the placeholder, so that the 1 stands for x cubed, then x squareds, then plain x's, then numbers. You cannot skip a space when you're setting up a synthetic division. That's why you have to fill in that 0. Now, as I go ahead and work this problem, I'm going to bring down the 1. So that's my third step, to bring down the first number. And then my fourth step says I'm going to multiply the last number on the bottom, in this case the 1, times the number in the box. So 1 times 1 is 1. I'll write my answer there. And then I'm going to add up these two numbers together. So 0 plus 1 is 1. I'll multiply again. 1 times 1 is 1. Negative 3 plus 1 is negative 2. Multiply again. Negative 2 times 1 is, let's see, negative 2 times 1 is negative 2. I add and I get a 0. Now this 0 on the end is my remainder. I have a remainder of 0, and the other numbers I can basically add variables back to get my answer. So in this case, since I did started with an x to the third divided by x should have been an x squared. So I have a 1x squared, and then if you want to, you can just count down. That's the ugliest x squared ever. 1x squared, and then a 1x, and a minus 2. So your answer should be 1x squared plus 1x minus 2. Turns out to be the same answer we had on the last one. And as you work these along, it is going to be the same answer every time. It's a good way to check your work. So I'd recommend pausing your video, trying C, and then I'll work through it with you, and you can kind of check yourself as you go that way. Okay, if you need some help on C, you start by saying, well, if x plus 1 equals 0, that must mean I have a value of x equals negative 1 right there. I'm going to put that in my funny little box, and then I'm going to put all my coefficients. 1, 2, negative 1, negative 2. There was no need to fill in a 0 because you notice I did not skip over anything. I had an x to the third, x squared, plain x, plain number. Everything was filled in, didn't have to fill in any zeros. I did have an understood 1 on my x cubed, but nothing really to fill in. Okay, I'm going to now try my process, which is to bring down my first one because there was nothing to add it to anyway. Then I'm going to multiply. 1 times -1 is -1. Add these up is 1. Multiply again is -1. Add up is -2. Multiply again is 2. Add up is 0. And that gives you the idea. 1x squared plus 1x minus 2 all the way across. You might want to pause your video, and then we'll try D. Okay, on D, I get x equals 2. My coefficients, once again, are 1, -1, -4, and 4. Always remember to include the negatives as part of your coefficients. I'm going to bring down my 1. So that gives me 1 times 2 is 2, plus -1 is 1, times 2 is 2. -4 plus 2 is -2. Multiply is -4. Add is 0. So some of my numbers are, then when you turn it into your variable, it started as an x to the cube. X cubed divided by x will mean it's an x squared, and then you just count down x minus 2. And we are having different numbers, but we're getting the same answer each time. If you go ahead and try E and F, you should get the same thing that we've had here. For E, for example, I would have, let's see if I can get this out of the way. For E, for example, I would have x equals -2. And then I'll try to use that. That will be a 1, a 3. You do need to fill in a 0 because you didn't have any x's, and a -4. In this case, I'm going to bring down my 1, and I'll have 1 times -2 is -2. Add is 1. Multiply is -2. Add is -2. Multiply times -2 is 4. Add is 0. So that's 1x squared plus 1x minus 2. Once again, you get the right idea. For the last one, I'll set it up. You should have a x equals 3, and your coefficients are 1, -2, -5, and 6. But if you do it correctly, you will get a 0 remainder and the same thing. One thing I do want to mention about having a 0 remainder is that means not only is, if I get a 0 remainder, I know that what I divided by is a factor, the thing I divided by is a factor, and my actual answer, the x squared plus 1x minus 2 is a factor. And the truth is, in this case, this factor that is my answer. In every case, I could have factored it out like this and taken one more step. So after you use synthetic division, a lot of times you've made it smaller, and it's something that will be easier to solve or perhaps even factor again. So the whole point of synthetic division is to divide out one factor by using a factor and x-intercept you've been given, and hopefully get a 0 remainder, so you'll have a pair of factors and your answer could be factored again to make further progress with the problem. One other thing worth mentioning is on down on this page. Let's see if I can drag this away. Probably be quicker to use this. Would pause, but this video tool doesn't let me write when I'm pausing. If I have something like this, it is possible that I could get a remainder. So we're going to do 13 together to show you how one like that works. And it's a different set of directions, but I'm still using synthetic division. So we're going to do it basically the same way. So if I do number 13, this time I do not have to figure out what x equals because it came out and told me. So I'll start with my x is 2. I will do my -3, my 4, my -17, and my -6. Then I bring it down. -3 times 2 is -6. Then I could do -6 plus 4. is going to be negative 2. Then I go ahead and multiply negative 2 times the 2 in the box is negative 4. I add negative 17 and negative 4 is negative 21. I multiply negative 21 times 2 is negative 42. And then you add again to get negative 48. Now in this case, you have gotten something that did not divide prettily at all. If you wanted to write this out, that would be negative 3x squared. And then I would have a minus 2x minus 21 with a remainder of negative 48. This is quite frankly about as ugly as you can imagine. And some of these do get pretty bad. So what this means is, first of all, you know that 2 is not a solution because I did not get a remainder of 0. So I know 2 is not a solution. That means x minus 2, which would be how I would write that if I got the 2 over there with the x, is not a factor of this polynomial. And also this answer here is not a factor of the polynomial. So I know that it's not a factor since the remainder is not 0. If the remainder was 0, it would be a factor. The remainder is not 0, it's not a factor. Finally, since my remainder is negative 48, that does mean that the point 2, negative 48 would be on my graph. 2, negative 48 is a point on my graph. And furthermore, if I evaluate it by plugging a 2 into that function, I would get an answer of negative 48. In fact, if you went and typed this equation here in Desmos and tried to substitute into a 2 or typed it in and did f of 2, you would get a value of negative 48. It's a way of evaluating and figuring out a point on the graph without using a calculator. If you didn't have a calculator handy, it's a lot easier than having to do 2 to the third power 2 squared and multiply all those large numbers. And when you use it to figure out your remainder and say that's equal to a point, it is called the remainder theorem. So that's what it's meaning in your notes about the remainder theorem. If you've got any questions, feel free to reach out on Zoom. I hope this helps you with today's lesson.